Okay, so you're staring down a system design interview. And those foundational architectural choices, like how you even organize your code, well, they can make or break your confidence, right? Today, we're diving deep into microservice repository patterns. Our mission is simple. Help you get comfortable discussing these patterns, the trade-offs, the real-world stuff, so you can explain complex ideas simply and, avoid those common interview gotchas.
Yeah, absolutely. And look, this isn't just about interviews. How you structure your repositories, it's fundamental. It really impacts how your teams scale, how independently your services can deploy, your whole development speed. It often comes back to Conway's law. Your tech architecture tends to mirror how your organization is structured. Tightly coupled teams. You often end up with tightly coupled code.
That really drives it home, how connected everything is. Okay, so let's start with something that sounds simple maybe, but for actual scaled microservices, it's a real anti-pattern. One giant repository, one giant build. Picture this. One massive repo holds everything. Your user service, catalog service, invoice service, all jumbled together. And any change triggers one single massive CI continuous integration build, and what comes out? Artifacts like user build 123, catalog build 123, invoice build 123, all with that exact same build number.
And that right there is where the problems really start piling up. Okay, maybe for a tiny project with just one team, right at the very beginning, it seems convenient. But fundamentally, it just violates that core principle of independent deployability that you want with microservices. Any tiny change, like a one-line fix in the user service, forces you to rebuild and verify everything, all the services. Think about your cycle time, how fast you get code to production. It just tanks. You're stuck waiting for tests on stuff that hasn't even changed.
And deployment must be a complete nightmare then. If everything has build 1, 2, 3, how do you even know what actually needs to go out?
Exactly. You don't easily. So organizations often just fall back into doing these lockstep releases, deploy everything together, which, again, totally contradicts the whole point of microservice autonomy.
Yeah.
Massive coordination headaches. And here's a critical interview point. If that single build breaks, everything stops. All development across all services, dead stop. So please, if you're in an interview, do not recommend this for a production microservice system. It is like the worst way to do a monorepo if you actually want independent services.
Okay, crystal clear on what not to do. So let's pivot. What's the more common, generally better approach? That's the one repository per microservice, right? The multi-repo pattern.
Yes, multi-repo. So your user service gets its own repo. Catalog service, its own repo. Invoice service, another one. Each triggers its own separate independent CI build. So you'd see user build 1, 2, 3, maybe catalog build 4, 5, 6, and invoice build 7, 8, 9. Different services, different build numbers, moving independently.
Right. And that sounds like what we want. True build isolation, independent versioning.
Exactly. Each service evolves at its own pace. Ownership is super clear. Mapping your CI/CD, pipelines, continuous integration, continuous delivery is pretty straightforward. You get maximum independence. That's a core goal here.
Maximum independence. Sounds like the holy grail. But there's always a catch, isn't there? What are the downsides?
Oh, there are definitely catches. A big one is cross-repository coordination. Git just doesn't let you make atomic changes across separate repos easily. This really bites you when you need to reuse code. Let's say your invoice service and maybe a payroll service both need some common connection library. So you put that library in its own repo. Fine, it builds independently, maybe becomes connection library, build 1, 2, 3. But here's the trade-off. If you update that connection library, say if it kicks a bug, you then have to go and redeploy every single service that uses it to pick up the new version.
Okay, so the DRY principle, don't repeat yourself, which we usually think of as good, can actually create this hidden coupling between services, like deployment dependency. Are you saying sometimes maybe duplicating a bit of code is actually better than sharing a library that forces coordinated rollouts?
It can be, yeah. It really highlights that tension between keeping things DRY and maintaining that microservice independence. You have to weigh the reuse benefits against the deployment complexity. So in an interview, if they ask, how would you handle a critical security fix in a shared library? You need to say, well, you update the library, sure, but then you have to trigger builds and redeployments for all the consuming services. It's coordinated, but critically, it's not necessarily an atomic single rollout.
Got it. And what about changes that span the actual services themselves? Not just libraries, like say I update an API in the inventory service and the shipping service needs to use that new API.
Right. In a multi-repo world, that's two separate commits, one in the inventory repo, one in the shipping repo, and then you have to be careful about the deployment order, right? Deploy the new inventory service first, then the updated shipping service that uses it to avoid breaking things. And this leads us to another really important interview anti-pattern alert. If you find your team constantly making changes that touch multiple microservices at once, that's a huge red flag.
A red flag. Why?
Because it strongly suggests your service boundaries are wrong, or your services are too tightly coupled. The pain you feel with multi-repo coordination, it can actually be a good thing. It forces you to question your design.
Huh. So the friction itself is like a diagnostic tool telling you maybe your architecture needs a look. That's interesting.
Absolutely. If making cross-service changes is a constant headache, step back. Are these services really independent? Should they maybe be merged back together? Sometimes that is the right answer. Practically speaking, yeah, working across repos can be annoying. Most modern IDEs, integrated development environments, handle multiple repos pretty well. Or you can write some simple wrapper scripts for the command line. So multi-repo works. Small teams, large teams. But listen to the pain. If coordination is constantly hurting, investigate your architecture.
Okay, so multi-repo has its strengths, but also these coordination challenges, these signals. What about the big alternative? The giants like Google, Microsoft, Facebook, Twitter, Uber seem to love, the monorepo, where, one single repository holds the code for lots of different services or projects.
Right, the Monorepo, its main selling point.
Yeah.
Atomic commits. You can make changes that span multiple projects, say, updating that inventory API and the shipping service client code all within a single Git commit. That definitely simplifies some development workflows. However, and this is super critical, a classic interview trap, an atomic commit does not mean atomic deployment. Let me say that again. Atomic commit is not atomic deployment. You still need to roll out multiple services simultaneously in production because of that commit. You're right back to violating independent deployability. The dev convenience doesn't remove the operational need for independent rollouts.
That's a massive distinction. Okay, definitely need to remember that one. So if everything's in one place in a monorepo, how do you even manage the builds? Doesn't that get incredibly messy?
It certainly adds complexity compared to multi-repo. A common way is mapping folders to builds. So a change inside the /dash/user service folder only triggers the user service build. Change files in both /dash/user service and /dash/catalog service. Okay, trigger both builds. But what if you have a common folder used by like 20 services? A change there could trigger, well, potentially 20 builds, right? This is where the big players invest heavily in smart build tools. Think graph-based tools. Bazel is the well-known open source example based on Google's internal tool. It understands the dependency graph and only rebuilds what absolutely needs to be rebuilt based on the actual changes, not just everything in sight.
Okay, so an interview question could be something like, how would you set up selective builds in a monorepo? And the answer involves talking about dependency graphs and potentially tools like Bazel.
Exactly. And that naturally leads to, well, when do you choose something like Bazel over more standard CI/CD tools? It boils down to justifying that pretty significant tooling investment based on your scale and dependency complexity. Another potential plus for monorepos is reuse. It can feel easier. Instead of packaging shared code into versioned artifacts, like NuGet packages, JAR files, and PM packages, you can sometimes just directly reference code from another project within the same repo. Feels more direct, less ceremony.
But then ownership. If everyone's code is in the same giant bucket, how do you stop it from becoming total chaos? Who owns what?
Good question. Martin Fowler talked about different ownership models. Strong ownership. You need explicit permission to change someone else's code. Weak ownership. You can change it, but they need to review it. Collective ownership. Anyone can change anything. For small teams, maybe under 20 devs, collective can actually work fine, surprisingly. But as you scale, you almost always need to move towards weak or strong ownership. And tools help here. GitHub, for instance, has code owners files. You can define mappings in a text file. Like you could write /build/log/@docticat, meaning the user docticat owns that directory and gets automatically assigned reviews for changes there. Or apps/@octicat/docs/@docticat. You can get quite specific.
It still sounds like making this work at, say, Google scale requires a huge engineering effort. The stories you hear.
Oh, it's monumental. Google built proprietary source control called Piper. Distributed linkers, custom IDE plugins, armies of engineers just maintaining the tooling. Microsoft, the Windows code base, 270 gigabytes? They had to build VFS for Git. Virtual file system used to be GVFS. It lets developers only download the bits of the repo they actually need. Lazy loading. These are amazing engineering feats. But it's another interview alert. Don't just say, we should use a monorepo, because Google does. You have to justify that level of tooling investment for your context, your scale, your resources. Most companies aren't Google.
Right, context is everything. And how mono is mono usually? Is it literally 100% of all code?
Rarely 100%. Even Google back in 2016 said it was about 95% of their code. Often you see variations. A popular middle ground is per-team monorepos. Each team gets its own monorepo for the services they own. This gives them some of the monorepo benefits within the team, like easier refactoring across their services, but avoids the massive org-wide tooling nightmare. It aligns nicely with Conway's law against structure mirrors the teams.
Okay, so putting it all together, who is the monorepo actually best suited for?
Realistically, the giant tech companies with deep pockets and engineering resources, or, at the other extreme, quite small teams, maybe 10, 20 developers, where the complexity is manageable, perhaps using tools like Lerna to help manage versions within the monorepo. It's the companies in the middle that often get stuck. They hit the scaling problems that need the big tooling investment, but they just don't have the resources or the bandwidth to actually build or implement it effectively.
So after exploring all this, what's your take? Which approach tends to be more, let's say, straightforward as companies grow?
Honestly, in my experience, multi-repo often scales more gracefully. The main draws of the monorepo, that finer-grained reuse, the atomic commits, they often don't fully outweigh the challenges you hit later. You can inadvertently encourage too many cross-service changes, ownership gets blurry, and that tooling investment hurdle is high. It can become a real production pitfall.
And I guess there's a sort of sunk cost fallacy too. Once you've gone down the monorepo path and invested, it's really hard to switch back, even if it's causing pain.
Absolutely. You see organizations start small with a monorepo, collective ownership, it works for a bit, then they grow, and migrating away becomes incredibly expensive and disruptive. So they just keep patching the system, investing more in a potentially suboptimal approach because they're already so deep in. Which leads to a great conceptual interview question. What factors influence your choice between monorepo and multi-repo for a new project? You have to talk about team size, expected scale, engineering resources, the nature of the services, or a scenario. You have a team of 50 developers across multiple services, monorepo or multi-repo. And the nuanced answer might be, well, a single org-wide monorepo is probably asking for trouble without serious tooling, but maybe per team monorepos could work as a compromise.
This has been incredibly insightful. We've covered the good, the bad, the ugly of repository patterns. Okay, let's switch gears slightly. Quickfire Q&A round. Listener, imagine you're in the interview hot seat.
All right, first one for you listening. Design a repository structure for microservices that need to share common libraries while maintaining independent deployability. How would you approach that?
Okay, my first thought goes to multi-repo. The shared libraries absolutely live in their own dedicated repositories. They get versioned like any other software artifact. When a library changes, you publish a new version, say version 1.2.3. Then the services that consume it make a conscious decision to update their dependency to use 1.2.3. They pull it in. This keeps the service builds independent and their deployments independent, even though updating the library required those downstream services to eventually redeploy. The key is that versioned artifact boundary.
Good. Focusing on that versioned artifact and the explicit consumption by services is key. Nice. Okay, next, you're facing constant cross-service changes at enterprise scale. What architectural and tooling strategies would you consider, regardless of whether it's monorepo or multi-repo?
Constant cross-service changes. My alarm bells are ringing about service boundaries first. Architecturally, the primary strategy has to be minimizing those changes. Strong API contracts, backward compatibility enforced, maybe event-driven patterns to decouple, and constantly reevaluating, are these boundaries actually right? Do services need merging? Tooling helps, but it's secondary to fixing the architecture. Things like automated contract testing and CI/CD pipelines, maybe sophisticated API gateways that can manage routing across versions. But really, the goal is to make those cross-service changes rare by designing for decoupling first.
Excellent answer. Tackle the root cause of the architecture before just papering over it with tools. Spot on. Okay, last one, the classic. Compare atomic commits in a monorepo versus the requirement for atomic deployments in microservices. Are they the same? Why or why not?
No, definitely not the same. That's the gotcha, right? Atomic commit is a source control concept. In a monorepo, I can change code related to service A and service B together in one single commit. It's a developer convenience. Atomic deployment is an operational concept. and generally an anti-pattern for microservices. It means deploying service A and service B to production at the exact same time, coupled together. That breaks independent deployability, which is a core benefit we want. So a monorepo gives you atomic commits. Great, but you should still strive for independent, non-atomic deployments of the services built from that repo. The commit convenience doesn't change the operational goal.
You absolutely nailed it. That distinction is fundamental. If you can articulate that clearly, you're showing a deep understanding.
Fantastic. So let's quickly recap the key takeaways from this deep dive. To walk into that interview with confidence, you need to be able to clearly explain the trade-offs monorepo versus multi-repo, considering team size, resources, scale. You need to recognize that constant cross-service churn is usually a symptom of bad boundaries, not a sign of good collaboration. Understand that crucial difference. Atomic commits are not atomic deployments. And finally, appreciate that scaling monorepos requires serious tooling investment. Think Bazel, think VFS for Git. It's not free magic.
Right. And maybe one final thought for everyone listening to mull over. In the world of microservices, sometimes that shiny convenience like easy code sharing or atomic commits can actually be hiding deeper architectural flaws. So ask yourself, what seemingly convenient choices might you be making today that could lead to significant pain down the road and slowly erode that independent deployability you're striving for?
That's a powerful question to end on. We really hope this deep dive armed you with valuable insights. If you found it helpful, please do hit like, subscribe, and maybe drop a comment. Tell us your thoughts on repository patterns or suggest other system design topics you want us to tackle. Your engagement genuinely helps us tailor these deep dives for you. And of course, share this with colleagues or friends also prepping for those tough tech interviews.